So we're discussing if spiders that we consume while we sleep really do control our brain. Now, we're not doing that. We're doing what? We're discussing that again? Why? Oh, they didn't like the first video? Was I wearing my shirt inside out again? Oh, they brought up some good critiques. Well, excuse me. I guess we're discussing lean mass hyperresponders again. Second edition, revised edition. Now, I released a video earlier in the week, or last week relative to whenever this video gets released, wherein I broke down the newest lean mass hyperresponder study. Don't worry, I'll explain what that is in a second. And due to a combination of my oversight and some goings on in the social media world, especially on Twitter, or X as literally no one likes to call it, that I was made aware of, I received some excellent critique which prompted me to take down that video. And here we are again to correct some mistakes and add some new information. So thank you for the resources, and let's discuss this study again. Okay, the crux of the matter is that a group of researchers wanted to find out if there was a relationship between ApoB containing particles like low density lipoproteins that circulate through our blood vessels and arterial plaque. More poignantly, if a particular subset of people called lean mass hyperresponders, or LMHRs, still develop arterial plaque like the rest of us mere mortals. To be defined as a lean mass hyperresponder, one should be lean, normal BMI, and have very elevated blood low density lipoprotein cholesterol, that's LDL cholesterol, from 190 milligrams per deciliter and up, as well as low triglyceride levels below 80 milligrams per deciliter, and elevated high-density lipoprotein cholesterol, or HDL cholesterol, above 60 milligrams per deciliter. These three markers, high LDL-C, low triglycerides, and high HDL-C, are called the triad. In addition, all of these blood parameters, the triad, occur on a very low carbohydrate diet. So in this study, the researchers recruited 100 of these lean individuals that had been on a very low carbohydrate diet for several years and confirmed that their LDL cholesterol had shot up by at least 50%, then did artery imaging to determine their baseline plaque in their arteries, and then again 1 year later to quantify if there was arterial plaque progression and how much. Now, in most studies published up to this point, the evidence resoundingly points to LDL particles, of which ApoB is a component, cause plaque progression. But is that necessarily always the case? Could a group of people not experience such an effect even though their LDL is extremely high? I'll skip closer to the initial punchline because there's several things to mention. If we look at the data, we see non-calcified plaque volume on the left and non-calcified and calcified plaque on the right. Now, I'm editing this video myself, so I can't get all fancy with the editing. For that, you're welcome to watch my original video. It's unlisted, but it's available in the description box. At any rate, both measures indicate an increase in plaque between baseline and 1 year results. So we'll return to this. So yes, LMHRs still experience plaque progression on average, but is that plaque progression tracking with the highly elevated ApoB level representing mostly by LDL particles in the blood? Here, again, for better visual explanation, check out the original video, but ApoB levels in right ascending levels are on the horizontal axis and the non-calcified plaque growth is on the vertical. Higher is worse. In short, because the red line doesn't move up much with increasing ApoB levels, there's no association. It should look more like this. This is relating to the same non-calcified plaque on the vertical axis to calcified plaque. So this would be interpreted as if a person has plaque already, specifically calcified plaque, there's an association with greater plaque growth over time. However, like I mentioned, that is not due to ApoB. This would be a bombshell, if true, because it goes against the majority of the literature, hundreds of studies that indicate ApoB and LDL cause plaque growth. Okay, so in pretty basic terms, that's what the study showed. There's some additional data that we'll get into, but these data are where I came to the two conclusions in my original post. One, that LMHRs still develop plaque, and two, that the plaque is not linked to ApoB, but linked to already present calcified plaque. Now, those two conclusions are correct based on what we see in this study. Of course, I had my own critiques that I'll reiterate in a bit, but I did overlook one aspect, and then I was made aware of some of the back and forth with the researchers on Twitter. I don't use Twitter, X, but people brought it to my attention, and I did do a bit of twittering or Xing. The latter sounds more like a homicidal maniac. And I ran across some further critiques that I'd like to include here, as well as some responses by the researchers. So I will provide links to the critiques and rebuttals in the description box. They're all excellent, but I won't be able to go over all of them, just the major points. So let's go over my oversight first. The researchers pre-registered the study, which means that they informed ahead of time what their primary outcome is. This is important because it locks in the researchers to report on that outcome and to focus their study on that outcome. And we can see that the researchers have their primary outcome as the percent change in non-calcified plaque volume. Now, the critique brought forward by the likes of Dr. Nicola Guess, Dr. Brad Stanfield, Dr. Kevin Klatt, and Alex Leaf, all of which have various formal medical and nutrition backgrounds, is that the primary outcome was not the highlight of the study when it should have been. Instead, the researchers focused on what predicts plaque instead of is there plaque, according to the critiques. Now, if we look at the graphs again, they mention PAV percent increase. That was 0.8%, but that's not the listed primary outcome. It's percent of non-calcified plaque volume, the left graph. Yet the percent is not shown and the numbers aren't mentioned. This is where Twitter twittered and asked for the numbers and received an answer that alarmed some people. An 18 millimeter cubed increase in non-calcified plaque volume, which is substantial. There was also a mention that the researchers had predicted a 7 millimeter cubed increase over the year, which makes the 18.8 number 2.5 times greater than the predicted. However, I should add that the 7 millimeter prediction is a guess for a power calculation for a group of people that have never been studied in this way. So it's really just a shot in the fog, and it's there to determine how many participants they need, including accounting for losing participants over the year, to detect change if there is one. Either way, the primary outcome change should have been reported in the study. A related critique is when comparing the percent PAV, that's the right graph, which showed a 0.8% increase in plaque, those values also don't look altogether favorable. So, if we look at these data, we see that the average growth of 0.8% in this study. Then we see a few different studies looking at different groups of people and their plaque progression calculated to be per year or annualized. One critique has been that looking at the average of 0.8% and stacking that up against some of these other groups, they were progressing at a similar rate. Now, most of these groups of people are people with diabetes, high blood pressure, high cholesterol, and so on. So if lean individuals who are otherwise healthy yet have this triad that we discussed earlier are progressing at a similar speed, well, that's pretty serious. Dr. Nick Norwitz and colleagues do have some answers, some explained in this interview, which is also linked for you to watch in full, and some that I'll pull from the depths of Twitterdom in a bit to reinforce Dr. Norwitz's point.
I was saying, like, part of the concern has been that maybe some of the message has been, that lean mass hyperresponders are safe. And you talked about plaque progression not being correlated with LDL, but the key being that there was plaque progression. And I think that's one of the messages that maybe, I don't know, has gotten lost or people are concerned isn't being portrayed enough. But I mean, there was plaque progression, but now the question is, what does that mean? And that's the harder part to answer when you have a very heterogeneous population, like you're saying.
Yeah. It's funny because a lot of the messages you'll hear from me and from other people's are actually consistent. They don't sound consistent, but if I say a majority did not have rapid plaque progression, that is totally accurate. It's totally accurate based on these data and the next paper we have under review. We'll go into a little bit more details there about what this means clinically. And we're also quite clear, like if you watch my video, I say very clearly, does this mean lean mass hyperresponders are immune to cardiovascular disease? No, it does not mean that. So me and my colleagues, Dave, Adrian, Matt Budoff, other co-authors, have been consistent about that message. And I think this is one of those moments where social media does what social media does and puts the more nuanced messages through a filter of social media, and caricatures get generated. And then they hold it up as, look, Nick, Dave, Adrian, they're saying X. And they're like, no, we're saying Y. And they're like, see, they're saying X. I'm like, now where are we at?
I don't know what the back and forth has been on social media and its completeness, but that last point is certainly something that can happen on the old socials. But the larger point that Dr. Norwitz points out is that the majority of the participants did not have rapid plaque progression and spoke to heterogeneity in the data, meaning that some people experienced extremely fast plaque progression and some experienced slower progression. And we can actually see that here. Those with already present plaque have extremely fast plaque development, but keep in mind that was still a minority of the group. The majority had much slower plaque progression. Those with zero calcium plaque progressed at 0.5%, so still progression, but slower than the average and much slower than the hypergrowers. Now, I should also note that most rebuttals, critiques to this study have focused almost exclusively on the 0.8% value, the average value, and haven't mentioned the slower progression in those without calcium plaque. Still, in the context of the other studies there, most are in somewhat health-compromised individuals, so the rate of plaque progression is still very likely greater, even in the slowest plaque-developing group, than when compared to a completely ideal group of individuals, something that I'll touch on later because this was one of my critiques in my previous video. Now, I also mentioned some answers from Twitter, which Dr. Norwitz also put together from Dr. Budoff, the senior researcher here. It's true that there's been consistency by the researchers. They've all stated that plaque still progresses, and it is true that the plaque progression is slower in the majority of the participants. But I would argue that is only relative to the faster progressors and maybe relative to completely metabolically compromised individuals, leaving them a bit in a middle ground. As a final point, Dr. Budoff was also asked about the plaque progression in an interview. Now you're going to see the same table that we've been referencing. And here is what his answer was in its entirety.
Yeah. So now if we look at supplemental table 1 from the KETO-CTA study, and we look at the all-comers, that with the baseline PAV is 1.6, and the delta PAV is 0.8, and that's for all 100 participants. Some people are interpreting that as saying that is a 50% relative increase, which is higher than any trial has ever shown and is incredibly concerning. And if you look at the numbers, they are correct. It is a 50% relative percentage increase. So how do you interpret that type of change?
Well, one, you can't do it based on a percent because the denominator was very low. The denominator was lower than most other trials. So when you have a low denominator, any number looks big. For example, if I tell you you had a calcium score of 1 and it went up to a calcium score of 3, you might say that's great. 1 and 3 are both very low calcium scores, and therefore I'm in great shape. And over 2 years or 1 year, that was a minimal change. But if you calculate a percent change, that's 200%. And if I tell you your plaque is going up by 200%, you should be panicked. And you should. So I think misinterpreting the data, we don't calculate a percent PAV percentage change over time. Because the denominators are so important when you think about those things. The other thing that you have to remember with the keto study is we took in patients who were across all types of plaque, but were on no other medical therapies. So they weren't on antihypertensives, and they weren't on statins, and they weren't on anti-inflammatories or aspirin. So we took a natural history, a treatment-naive population, and said, what is the effect of a high LDL induced by the keto diet on plaque progression? And we found that it was not related to the LDL. So that is the answer of the question. The fact that some of these patients had a lot of plaque and should be on a statin, or that they had a lot of plaque and they should have been on other therapies to slow down plaque progression, is a whole nother question. And we have recommended that they go on other therapies once we identified them as having plaque. But this was a true treatment naive population that was just using keto diet for overall health. And we thought that they were all lean, healthy people. And some of them had a lot of plaque at baseline, which to me was, I think, a difference between the other studies. All the other studies use 2, 3, 4, 5 background therapies to treat patients. So you can't say a treatment naive population progressed more than a treated population and be surprised. That's just too naive to even think about.
Okay, 2 main points there. First, the question is put out there as a critique based on relative increase in plaque. And I agree with Dr. Budoff's point that looking at relative increases yields astronomical numbers when the baseline plaque is, well, already low. However, the critique that I've seen has been about the absolute values, not the relative values. So this doesn't actually address the primary criticism that I've seen repeated. On the other hand, the second point about LMHR individuals being a treatment naive population, as in not taking any drugs or any additional interventions, would be an excellent one if only the comparison groups were in equally assumed lower risk individuals. And even if we restrict our comparison to those with no calcified plaque, the progression is still not ideal. So all in all, I agree in theory, but I don't think that it addresses the critiques offered, especially the aforementioned Dr. Guest, Dr. Klatt, and Mr. Leaf. Anyway, there is a way to find out the answer, and it's the primary critique that I've had since learning about this study a year and a half ago. We need an adequate parallel control group. People who have normal blood pressure, healthy weight, normal cholesterol, normal blood sugar, and so on, and compare the rate of plaque progression in those individuals against the LMHR individuals. That's really the only way that we'll get clear answers on the level of risk by plaque progression. But like I mentioned last video, this stuff isn't cheap to finance and it takes a whole lot of work. So we can critique all that we want, but we should also acknowledge the amount of work that has to go into this research too. Anyway, let's move on to the final major critique that I'll cover here, and then we'll put everything together. The final one was the lack of association between ApoB and plaque development. Again, if that holds true, that is a bombshell. Now, I've seen far fewer critiques of this data than of the last point, but there have been a few. In fact, Dr. Norwitz brings up a great point that does seem a bit hypocritical at first glance. So, to set this up, it's been said over and over again that the greater one's blood LDL and ApoB levels are, the greater one's cardiovascular disease risk, because there's a linear concentration burden. As LDL and ApoB go up, there's an assumed faster plaque progression because you have so many more particles that can cross into the subendothelium and form plaque. And yet, now some of the critiques are that there's a threshold level, and once you cross that threshold, the relationship may not show.
Well, I think the point of contention that I've seen is that there's a threshold level, that once you're above a threshold level, it doesn't matter. Like, it doesn't matter
Exactly.
if you're 600 or 200, it's just all so high that it contributes the same. I mean, there's no real evidence, I don't think, to support that, but it's a hypothesis, right? It's a hypothesis that should be entertained just like any other.
I suppose, but I've never heard that prior to this point in time, prior to these data. Like, that would be a new supposition, that there's a saturation effect for LDL levels, such that if you have a 200 or a 1000, it doesn't make a difference. That actually counters a lot of the pre-existing notions, like status quo thinking around ApoB, where they talk about ApoB or LDL milligrams per deciliter year exposure. So multiplying the amount by the duration. So if you're saying there's a saturation effect, you're effectively taking the preponderance of evidence that everybody talks about and throwing it out in order to make an argument. I just want to point out that irony because it's not subtle.
That critique, on the face of it, is weak, and I have to agree. We can't move the goalposts on that one, especially when it's been repeated so many times. In fact, I had this same discussion with Dave Feldman, another one of the researchers and spearheads of the lean mass hyperresponder movement. Yet, there are some other critiques that I'd like to bring up for completeness. For example, one critique is that the researchers are only including the top band of high LDL, as there's no one with moderate or low levels of blood LDL ApoB. As a result, there isn't enough difference inside the group to create a relationship. Another possibility is the fact that the study is powered for its primary outcome, so plaque progression. Remember the 7 millimeter cubed that we discussed earlier. That doesn't mean that it's powered, as in has enough participants to detect a relationship in ApoB, however. The first critique I don't find too convincing, especially as some people have used smoking as another example. If you smoke 3 packs a day, smoking 4 packs a day isn't going to lead to any detectable increase in risk of cancer because, well, the majority of the effect occurs from 3 packs. Generally, that's true, but smoking doesn't necessarily follow the same rules as ApoB, where increasing blood levels is ever more a problem. Now, the second argument is a possibility. It's one of those situations where we just don't know. It's the same issue with any secondary outcome, which is what this is. Now, there might be some other critiques, but they certainly haven't been as vocal as the first point, so I'll leave it there on that front. Okay, now, all that being said, where does that leave things? Now, before that, I mentioned this in the last video, but I'll be doing a live session that will include more discussion with the Physionic Insider community, along with many of my other analyses. If you're interested in joining, the link is in the description. Well, the emotionality around this topic has been really something to behold. I mean, certainly for good reason in some respects, but we can say a few things definitively. Revisiting my previous conclusions, as I stated then and state now, lean mass hyperresponders still develop plaque in the arteries. Now, some added context indicates that some develop plaque at an extraordinary rate, and others develop at a more tempered rate. Another thing that we know is we don't know why. Keep in mind, these are supposed to be metabolically healthy individuals, and if the ApoB lack of relationship stands, that leaves a gaping hole to find out what is causing this atherosclerosis risk. As for what we aren't entirely sure about, ApoB is still not correlated to plaque progression, and critiques are less obvious, although addressing those that do exist, i.e. like an underpowered analysis, for example, would go a ways to bolster or weaken these findings. A few final things to acknowledge. The researchers should have reported the primary outcome, including in the abstract, and based on the current evidence that everyone agrees on. If I were a lean mass hyperresponder, I would certainly try to get a CT angiogram to determine my current risk, if there's plaque or not. Then, due to the varying levels of uncertainty related to this ApoB relationship to plaque progression, and considering that I'm lean and otherwise healthy, I would tackle my sky-high LDL levels just to be safe until more of these questions can be answered. Okay, that's the end. But let me also quick say thanks to all the people who commented under my takedown notice of my last video. I did not expect such an overwhelmingly supportive note. Anyway, the goal has always been to get to the truth, even if I have to correct myself, and constructive criticism is part of the process. So thanks again, and thanks for your support. By the way, apparently we actually don't consume spiders in our sleep. That was a myth purposefully propagated to show how easily misinformation can spread. But if one did get consumed, there's a chance it could control your brain. There's always a chance. See you next time.